Take a close look at this setup. A hand pushes a flat wooden board forward, but the small wheeled cart underneath it shoots past. The hand moves the board at a slow, steady pace, yet the cart achieves a much higher velocity. It is visibly traveling faster than the single force pushing it. This creates immediate cognitive dissonance. According to our basic intuition of thermodynamics, an object should not be able to generate more energy or speed than it receives from its power source. If the board is only moving at 1 mile per hour, where is the cart harvesting the extra kinetic energy required to hit 2 or 3 miles per hour? Solving this visual glitch requires us to stop looking at the push from above and instead zoom in on the mechanical cheat code hidden underneath. The investigation starts at the contact points, where the vehicle touches the moving board on top and the stationary table on the bottom. The cart's extreme size difference between the inner spool and outer wheels creates mechanical advantage. Sharing an axle, 1 inch of spool movement translates into multiplied distance for the wheels. Counterintuitively, as the board moves forward, the wheels actually push backward to gain momentum. The cart uses the static table as a fulcrum to actively harvest the relative velocity between the 2 different surfaces it is touching. This transmission system acts as a bridge between 2 environments moving at different speeds, converting that relative motion into a higher output velocity. This specific mechanical trick was so unintuitive, it sparked a massive civil war among internet physicists and academic professors. Science communicator Derek Muller brought the paradox into the mainstream, arguing that the same logic could be applied to wind. A physics professor challenged the experiment's legitimacy, escalating the debate into a public confrontation over the laws of motion. They eventually settled on a $10,000 bet. Muller had to prove the concept of traveling downwind faster than the wind in a completely uncontrolled environment. The core of the academic skepticism rested on traction. Experts assumed the trick only worked because the solid wooden board provided a rigid grip that the wind simply could not replicate. Winning the bet required abandoning the safety of the laboratory table and building a machine that could apply this gearing logic to the open air. That machine is the Blackbird Land Yacht, the ultimate macro-scale proof of the concept. The desert floor acts as our stationary table, while the blowing wind replaces the moving wooden board. The Blackbird's propeller is driven entirely by the wheels on the ground. As the vehicle moves, kinetic energy flows up from the wheels directly into the spinning blades. The propeller operates like a sail on a continuous tack. It pushes backward against the air to maintain a lift-to-drag ratio that forces the vehicle forward faster than the wind itself. By using the rigid earth to pry itself forward through the air, the vehicle literally outruns its own pusher. The field tests proved successful, the physics held up under scrutiny, and the academic consensus shifted. Harvesting the energy gradient between any 2 moving media makes the impossible mathematically sound. Reality isn't broken. It simply rewards those who look past the obvious push and understand the hidden power of mechanical leverage.